Good morning, everybody. Myself, Dr. Divakar Kichunarkar. I am a senior lecturer of Praveen Patil Diploma in Engineering and Technology, Bhayandar. So last time we have to explain the combination of series capacitors, and at that time we have to derive the equation of series capacitor 1 upon Cs equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. Here is 1 upon Cs is the equivalent combination of series capacitance is equal to the reciprocal of sum of individual capacitance or sum of capacitance in series. So today I will derive the equation of parallel capacitors. So this is the circuit diagram of parallel capacitors. Here is C1, C2, C3 be the capacitors which are connected in parallel position in the circuit, and V be the potential difference applied in the circuit. In this circuit, current flowing through the circuit. So V be the potential difference, Q be the electric charge, and this Q equal to Q1 plus Q2 plus Q3. Total electrical charge depend on the capacitance, keep in your mind. So therefore, here is C1, C2, C3 be the capacitance which are connected in parallel position in the circuit. Q1, Q2, Q3 be the electrical charge or electric charge depend on the capacitance, keep in your mind. In previous circuit diagram, V be the potential difference, and that potential difference depend on the capacitance, keeping your mind. In series combination, potential difference depends on the capacitance. But in case of parallel capacitance, electric charge depend on the capacitance. Electric charge depend on the capacitance. So this C equal to Q upon V. This is the definition of capacitance, and this definition we have to use in this equation or in parallel capacitor. So C equal to Q upon V, this is the definition or this is the mathematical equation of capacitance. Here is C be the charge, C be the capacitance, Q be the electric charge, and V be the potential difference or applied. Q equal to CPV. Suppose we get C equal to Q upon V. So Q equal to C into V. So CP means parallel plate, parallel capacitance, equivalent parallel capacitance, keeping your mind. And Q be the electric charge, V be the applied potential. So Q1 equal to C1V, Q2 equal to C2V, and Q3 equal to C3V, keeping your mind. So again I repeat this equation, C equal to Q upon V. This is the definition or this is the mathematical equation of capacitance. So Q equal to CPV, Q1 equal to C1V, and Q2 equal to C2V, and Q3 equal to C3V. So this four equation we have to put in this equation. Q equal to Q1 plus Q2 plus Q3. So put the value of Q, Q1, Q2 and Q3 in equation A. So equation A becomes, this is our equation A, Q equal to Q1 plus Q2 plus Q3. So Q equal to CPV, Q1 equal to C1V plus Q2 equal to C2V and plus Q3 equal to C3V. So from this equation we have to take out common V इन RHS। ये RHS में से V कॉमन निकालने का है। So take common V on RHS. So CPV as it is. Here is V common. So C1 plus C2 plus C3 as it is in the bracket. So this V and this V get cancelled. So our equation Cp equal to C1 plus C2 plus C3. What is your equation? Cp equal to C1 plus C2 plus C3. In case of series combination, 1 upon Cs equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. But in parallel capacitors, Cp equal to C1 plus C2 plus C3, and this is our equation, combination of parallel capacitance. So from this equation we can say that the equivalent capacitance in parallel, is equal to the sum of capacitance. Sum means addition. So sum of capacitance in parallel combination. Sum of capacitance C1, C2, C3. Sum of capacitance in parallel combination. So this is the statement of parallel capacitance, combination of parallel capacitance. This is the statement and this is the formula, Cp equal to C1 plus C2 plus C3. So equation B shows that the combination of effective capacitance, this formula shows that the combination of effective capacitance in parallel. So here is law of capacitance in parallel. What I am saying, the equivalent effective capacitance in parallel is equal to the sum of capacitance in parallel. Sum means addition. So sum of capacitance in parallel. So this is our statement of equivalent effective capacitance in parallel or combination of parallel capacitor. So again I repeat this, Cp equal to C1 plus C2 plus C3. This is the formula for parallel capacitance, or our statement, the equivalent capacitance. This is Cp is the equivalent capacitance in parallel. Cp is equivalent capacitance in parallel is equal to the sum of capacitance in parallel combination. Sum of capacitance in parallel combination. So this formula is useful to solve the numerical problem, and generally numerical problem must be asked in your examination according to MHPT. So student, today I stop here. Thank you very much.